Yes.
Yes. So let's start with that. Let's start with some key aspect. Let's start with some key aspect. We said subheading, our heading is construction of ray diagrams. Construction of ray diagrams for images formed by curved mirrors. Images formed by curved mirrors. That's our heading. So we're going to look them one by one for the curved mirrors, the concave and what? And convex. Like you can see on my screen there. But let's start with the concave. Let's start with the one for concave. But before we look at that, let's take some few steps. Let's look at some few steps that is very important in this. Let's say curved mirrors also reflect light, and form images, Full stop. Subheading, again, sketching. How do we sketch? Sketching a curved mirror. Sketching a curved mirror. Sketching a curved mirror. We said the mirror is represented. The mirror is represented by a straight line. It's represented by a straight line. Because the mirror is represented by a straight line because we treat only rays that are close to the principal axis. And a small section of the mirror. Full stop. So what are we trying to say here? So members, when we are drawing ray diagram, we have seen how concave mirrors look like, we have seen how convex mirrors look like. But when we are drawing the ray diagram now, we don't draw the whole curve. We just take a small section of it. So if this is it, let's say for concave mirror, so what we do, I just draw a line. This line is going to present the pole of the mirror. Are you seeing that, members? Are you seeing that? Members, are we together?
Yes, teacher.
I just draw this. Then to show all of this is presenting the mirror. All this line is presenting a mirror. But to show which type of mirror you are talking about, you just draw a small curve here. We know that this is our concave. Then you draw this, just a small one of it, just to show that a section of it, sorry. But now all this line you are seeing here is representing the mirror. All this line is presenting the mirror. That's how we draw a concave. Then for convex, we also do the same. For convex mirror, we also do the same. We draw a line. This line is presenting the mirror. Then we draw the principal axis. Sorry, we draw the principal axis. Then we know that for concave, so just I put it like this, which means the object is this side. Then we shade inside because we know that it's curved inwards like that. So this is it, a concave. This is the pole of the mirror. This is also pole of the mirror. That's how we present the mirror when we come to the construction of the ray diagram. Okay? Are you together, members? So you draw a vertical line, then you draw the principal axis. Then to show which type of mirror, you just draw a small curve. If it's a concave, that's how we draw it. If it's a convex, this is how we draw it. So now let's look at the steps. Let's go to the steps. Subheading, rules followed in ray diagram construction. Rule follows in ray diagram constructions. We said in ray diagram construction, of locating the position of images formed by curved mirrors, comma, we make use of 2 out of 3. We make use of 2 out of 3 useful rays. 2 out of 3 useful rays. Full stop. This includes. So we want to, there are some rules that we need to follow when we are constructing this ray diagram. There are 3 in numbers, but to come out with a good ray diagram, at least we have to use, to say that you have constructed a good ray diagram, you must use at least 2 of the rays, 2 or 3 of the rays. But at least if you have used 2, that one we can say is a good ray diagram. So what are the first rule? What is the first rule? Rule number one. A ray originally parallel and close to the principal axis. Parallel and close to the principal axis. Passes through the principal focus. We say principal focus is the same as the focal. Is the same as the focal what?
Point.
It's the same as the focal point. After reflection. So that's the first rule. A ray which is parallel and close. We said a ray which is parallel and close to the principal axis. That ray is called what, if you remember? What is that type of ray? It's called what? Because we have secondary rays, we have parallel rays, then we have marginal rays. The one which is parallel and close is called what? Who can remind us? The one which is close and parallel to the principal axis is called what?
Secondary rays.
Are you sure?
Secondary rays.
No.
Parallel.
Parallel is what? Parallels of
Parallel those.
rays, okay? Yes. Let's see that. Let's see how we construct that one. If this is my mirror, the pole of the mirror, like that. So let me say I'm drawing for a concave. For concave, which means it will just put like that, a small. So I told you we shall have what we call the principal focus or the focal point. But I told you when you are drawing it, the distance from here must be equal. The distance must be equal. Okay? So it like this one is how many? This one is 3. So it must also be approximately equal. So which means this is going to be our center of curvature. So which means assuming there's a ray of light which is parallel to the principal axis, which means it will run like this. It will be like this, parallel to the principal axis like that. It will be reflected. It will be reflected through the principal what? It will be reflected through the principal focus like that. So incident, reflected, like that. That's what we are talking about. This is it. This one is a concave. A concave what? Mirror. Are we together? Members, are we together? A ray which is parallel to the principal axis, it will be reflected through the what? Through the principal focus. That rule is very important. Don't